Okay, so you need to your sound is on.
My sound. I'm very
It's
sorry.
on. You should be sorry. 'Cause
Like,
that's going to be.
you saw me turn it off before.
No, I didn't. That's now going to be live streamed. Live. Hello, can you hear me? Does this sound okay? Oh, that sounds brilliant. That sounds absolutely brilliant. Okay, that's now muted, so hopefully they can hear me now. Started work with local speakers, companies and organisations as well, so trying to get various speakers in, working with sort of companies like this, Oakland and Gravitas, as you saw last time round, and Hippo as well. So trying to work with a lot of the communities, tech companies, and try to grow that community here in the north as well. So a quick intro on Dr. Phil. So he's going to be talking about language models and are they better UX than for analytics. He's going to explore what's so-called AI agents, how they work, what their magic is, and the fun things you can do once it's connected to your data. Dr. Phil is a software engineer and data scientist by trade, CEO of Winder.ai, and holds a PhD in mechanical engineering, electronic engineering from the University of Hull, where he lives in Yorkshire with his brewing equipment and his family. Don't know how that works. How does that work?
Well, not the order of importance.
Oh, right. Yeah, I was going to say family at the end.
Should switch that around.
But no, looking forward to that. Then we've got Lewis Holmes coming in, so we'll be looking at beginner APIs in Power BI. So another interesting session, looking at securely authenticating APIs directly with Power BI, techniques for working with APIs, and handling authentication with tokens and that type of thing within Power BI as well. A little bit about Lewis. He's an Azure data platform consultant, CEO of LH Data Consultancy, and he's worked with Microsoft Power BI Stack or BI Stack, should I say, for more than 15 years. Okay. Some socials. So if you like to connect on the socials, really good if you could do that. It helps the sort of industry. It helps a user group spread awareness, gets more people interested. Again, shows your sort of enthusiasm in wanting to go and learn at these events as well. Really helps going forward as well for looking for new roles and that type of thing as well. Okay. Just a quick update about SQL Bits. So I mentioned already SQL Bits is coming up next month, so 18th to 21st of June in London's Excel. There'll be multiple topics covered, as you can see, just some of these themes down here: decision making, leadership, databases, application development, reporting, visualization. So there's a lot of stuff going on at SQL Bits, and I think there's a free Saturday as well. So I think you can visit free on the Saturday, and the other sort of days are paid. So if you did want to go check that out, SQLBits.com, there's still tickets available. And actually, we're going to get discount codes because of the user group as well. So if you do want to go and you are going to book, let me know, because we have got some discount codes coming through because of the Leeds user group as well. Okay. So if you want to go to that, let me know and we can sort that out. But I'll post that out during the month anyway. Training workshops. Oops.
Will you be there?
Will I be there? I might be there on Saturday. I've been doing some workshops recently, so we just finished the data modeling for Power BI, which was heavily based on sort of Power Query and trying to create a really sort of focused data model for Power BI. The next one we've got is a dashboard design masterclass, so creating nice visually appealing dashboards and reports in Power BI, getting that UX and user interface right as well. So that's 6th of June coming up in Manchester. So if you'd like to attend those or want more information, then just give me a shout. Okay. So yeah, we're going to sort of rework these. So once this last one's done, we're going to sort of throw out some more dates for the same sort of number of sessions again. So hopefully the second half of the just after summer, hopefully we'll be having those sessions as well on a monthly basis. Yeah. So next month, because it's SQL Bits, it's been quite a challenge actually to get some speakers lined up during the same week. So I'm still working on a couple of the speakers' locations as well. So it could be that we give it a miss next month and come back in July. But I'll keep you informed of all of that over the next sort of couple of weeks anyway. Okay. Okay, so please give a warm welcome to our first speaker, Lewis Holmes. If you'd like to come up, Lewis.
Right, we just need to move some wires around.
So there's one.
So I've just put it in. I might need to leave and come back in. Because it's not showing that. That's not for a second. Stop showing that. So it needs to go. Maybe it's this. Do a bit on here. Right. Okay. So it's there now. No. It's not showing up in here. Let's look that again. It should just be here because it did it online. Same thing. Yeah. If I leave and come back in, they'll pick it up. Try it. Stage.
Unmute me and I'll mute you. Okay, good to go.
Sorry about that, guys. A few technical problems there, getting it all configured to work on YouTube as well. But hi, yeah, as Sheb said, my name is Lewis. I'm an Azure data platform consultant. I've been working in the field for approximately 15 years, specialist in the Microsoft platform, so things like Synapse, Azure SQL, Data Factory, Power BI, all that kind of stuff. Yeah, and I've worked as a consultant at a few different places, including Diageo, Microsoft, RELX, currently working at the consultancy house Calibri, and my LinkedIn's there if you want to connect. So today I'm here to talk about APIs. And first of all, I'm going to give you a quick overview of what an API actually is. Then I'm going to talk around authentication a bit, because that's always the bit that gets everyone stuck, and it's the most problematic bit working with APIs. Then I'm going to run a demo. Most of my talks are going to be in Power Query, actually interacting with APIs. So we're going to set up Power Query to do that. We're going to authenticate to an API, and then we're going to fetch some data back from it. So what is an API? Well, essentially, it's a way for computers or programs or services to programmatically interact with each other. And in my scenario today, I'm going to be using Power BI, or rather Power Query. And that's going to send a request. That's going to go over the internet. And our API that we're going to use for the demo is the Power BI API itself. So you might not know, in the Power BI service, there's an API you can use. You can do an awful lot of stuff with it. So we're going to use the Power BI API as the example today. So we're going to send it a request. That will go off to its database. And we're going to try and build a report up that tells us what users have access to what workspaces. Fairly straightforward, but it's a task I've had to do a few times at a few places. And there's a few API calls you have to do to make that work. In practice, an API call is literally a web request. So you can see like the URL there. It's the same as what you put in your browser, but often you have to send extra things along with it to make it work. And if you do that correctly, you should get some nice data back, something like that. And the Power BI API is nice because it's well documented, it works, it doesn't generally go down, and it gives you JSON data back, which Power Query parses really well. The API is essentially just coded by someone, and it doesn't necessarily have to abide by any standards. Power BI API does, it will return JSON, but you could get XML, you could get CSV, they could just dump out a load of text. Ultimately, you're at the mercy of the API provider. And yeah, just talk a bit around authentication. If you're doing anything serious with APIs, you are going to need to authenticate yourself. Most APIs do require it. At a basic level, that could just be an API key. So you'll go to your vendor, they give you a key, you embed that in the request, and that could just be to keep track of the amount of requests you're making, so they could limit you maybe, or they could charge you, or they could use it to kind of segment your bit of the data. Another way is kind of basic authentication, so you'll be provided a username and password, you do some kind of encoding with that, and then you send it along with your API request. The version we're going to use today, though, is OAuth. This is what the Power BI API uses. And to do that, first of all, you have to go off and get a token. And so you go, excuse me, I want to use your API, can I have a token? You get something back. And then you make your other requests to get the real bit of information that you're after. And more specifically on terms of the Power BI API, as I said, it does use the OAuth. And in the demonstration today, I'll be writing a few bits of Power Query. So the first one will be to go off and get that token. And then we'll get the token and that'll be reused as, in the subsequent steps. If you're doing this in a serious way in Azure, you're going to want to have to set up something called an Azure application service principal. It's a bit out of the scope of this talk today, and I've already created it. But Azure application is just an entity that can live in Azure that you give permissions to. So I've created one that can get into the Power BI API. The creation of those things are practically straightforward, but often very difficult in big organizations. You'll have to go to some kind of administrator, explain the permissions you want, and then there can be bureaucracy with that. I created mine in 2 minutes because it's my Azure estate, but I've been at big companies where it's taken weeks to get these things created. Just the way it goes sometimes, unfortunately. And I'm going to jump into a demo now. So I'm going to start off by going to my browser. And so if I stop sharing, if I stop this, so Sheb, I might need some assistance because it's not. I'll just perhaps if I share the other one.
That's really, you should just be able to share. You should duplicate it now. Is it disconnected?
All right. Okay, that'll do. So what way? I need it duplicated, so let's go and do that. I just get all the options.
Yeah, on the top. Extend.
The first time I plugged it in, it defaulted to that.
Oh, did
and
it?
It changed.
Okay.
It's fun. Is my screen coming through still?
Yep.
Yeah. So sorry about that. So I just wanted to show you how the service principal looks in the Azure service. I've created my one. Something weird is happening with my display here, Shep.
Is it this section?
It keeps wanting to extend. I've created it in the Azure service. The important bits we need to know is this client ID, which I've saved, the tenant ID, which relates to my Azure account, and then I've created a secret for it. So the combination of those 3 bits of information means that I can authenticate against the API. So how do you do that? So if you go to the documentation page, you'll get given something like this, which is a bit daunting. So you need to make a request to a specific URL, and that URL, you need to give it your tenant ID and then the rest of that, and then you have all this gibberish down here. And this is often a bit impenetrable. So if you're working with APIs, I would strongly recommend you use a tool called Postman. There is a web version of it, which I've pulled up here. And it allows you to really easily prototype these requests up and to confirm whether they're working or not. So I've pre-populated this with the URL that I'm after. So I've slotted in my tenant ID here. I've also told it, and if you go back to the documentation page, it says this needs to be in content type URL encoded form. So Postman has the option for that. So I've told it it's the URL form, and then I provided the 4 bits of information it needs. We're asking for a client credential. The scope for Power BI is always this, but if you're going into different bits of the Azure estate, the Graph API or something else, that'll be different. That's a mostly Microsoft specific thing, but yeah, you're asking for a token within the scope. And I've got my secret, which I'm going to delete later, and the client ID. So the idea is in Postman now, you can hit send, and that goes off and sends it. You get a nice 200 OK thing, and you get some JSON. And this access token is what we need to generate in Power BI in order to access the API. And you can also see the token has an expiry date or time. So that's an hour from now. So when you ask for a token, in Azure anyway, by default, you'll ask for an hour. So I'm going to go off and try and replicate this now in Power Query. So let's see how that goes. So I'm going to jump straight into the Power Query editor. And those 3 bits of information, the client ID, the client secret, and the tenant ID, they're kind of things that might be subject to change. So it's a really good idea to set those as parameters. So then that'll be exposed in the Power BI service. So if your administrator decides your secret is compromised and changes it, you can just jump in and change the parameter. Your whole report doesn't break. So I'm going to go off and just create these. With parameters, you need to set them as type. Well, they can't be a type any if you want to be able to change them in the service. And I'm just going to populate these values as a starting point. And the client ID is that one. So I lost my mouse then. Cool. So that's the first bit. We have those values saved. We'll be able to change those later in the service if we need to. And I'm just going to now go and do a new blank query. And this is going to be mostly in the advanced editor. So if you've used Power BI before, you've definitely used Power Query. And most use cases are around loading data, apply some transformations. You might be grouping, adding columns, removing rows. And it's very kind of linear. You do one step, and you follow the steps all the way down. It doesn't necessarily have to be like that. Like you can use it as a bit more as a programming language. You can set variables up, reference them later. You can create functions. And there is an awful lot more to it than what you just see when you're using the GUI. So that's exactly what I'm going to do here. So first of all, we need a URL that we're going to go to. So I'm going to put that in a variable. And I'll be jumping back and forwards a bit on this while I set it up. An auth URL. Now, if we carry on with our work now and ultimately make the request to this URL, you won't be able to change it in the Power BI service because you can't have dynamic URLs. So what you have to do is separate it out. So we have this part here. So let me grab that. So you have everything up to the .com. There's one part, and then the way Power Query references the other bits is it calls it a relative path. So I'm going to stick that in a variable, and I'm going to make the tenant ID bit dynamic. And don't forget the commas. So later on we can reference this, and it's not going to prevent it refreshing the service because this is dynamic, referring to that parameter I just set up. Okay, and what else do we need? Well, we need to tell it it's of type form URL encoded, and that comes through in the headers. So you can click on the headers in Postman, you can see it's already kind of added that. But in Power Query, we need to tell it. And I don't want to mess up the syntax, so I'm going to copy it from here, which is this guy. So this is just setting up the headers, and we're telling it the content type is going to be that form URL encoded. Right, we're getting there. The next part is just the body of the request. So you can see in Postman we had 4 different variables: client ID, client secret, scope, and grant type. And there are a few ways to kind of reference this inside Power Query, but what I like doing is creating a list like this, and then we can add multiple items. So we're going to do a client ID, secret, scope, and grant type. And we know all the variables for those. The client ID is in the parameter, that parameter. The secret is here in that parameter. And these next two can be hard-coded, so I'll just grab them. And the grant type is client credentials. Okay, so we're getting pretty close to be able to kind of send this off as a request. But the fact it wants to be URL encoded means we can't just batch this up and send it. We do need to apply that encoding. So there are a couple of functions, which again, I'm not going to attempt to copy here. So this creates a binary representation of that. So it's using inbuilt Power Query functions to turn the text into a binary. And this part of it is URL encoding all of this data. So now we can actually make the request. And that's so we can say the auth is web.request. Not that one. Sorry, it's web.contents. And this is not a very clear function to understand. But again, Microsoft do document these things. So we have a page here, web.contents. It says it takes 2 parameters. We've got a URL, so we know that. But it's asking for this options as a nullable record. Like, what does that mean? But it essentially means you have the option of putting one or more of these bits in there. So I have some content I want to send. I've got a relative path. I have some headers. In other APIs, you might need to specify specifically a key name like this. I've never used that. You can tell it to retry if it needs to. And you can send query parameters as well. So, okay, we should be able to do this. So back in here, we know our URL. And it's come up again, options as a nullable record. And what we could do now is start typing all these in. Headers is equal to the headers. But it can get quite long and a bit messy. So what I prefer to do is just separate it out into a line beforehand. And again, this is just going to be a list, and then I can reference everything I've had before. So we've got a relative path, we'll have some content, and we want the binary version of that. So I can pick that step up. And then the final one is the headers. So now instead of having kind of all of that square bracket stuff in this line here, we can just refer to it like that. And if I've typed all that out correctly, I haven't quite, but it's not a disaster. So yeah, I think that's working. The first time we try and connect to it, it's going to ask you about credentials. And it's a bit weird, this counterintuitive, because you're sorting out the authentication yourself, you can tell the Power BI service or Power BI desktop here that it's anonymous. Like you're not trying to sign in with an organizational account or any of these other bits. You're doing the authentication for yourself. So as far as Power BI is concerned, it's anonymous. And that doesn't look too bad. We'll figure out what that is. And the good thing is you can always revert back to Postman here. And you can say, well, it's working here. What have I done wrong over there that isn't making it not work? So we got login.microsoftonline.com, OAuth token. And another thing you can do is in the URL, in these steps here, you can go down and you can see everything. So there we go. I missed a slash off there. So I just put that in. And now if I jump to the bottom, we're in a good place. So this is the payload we've got back from the API. We can double click on it. And at this point, Power Query is doing its magic. It knows it's JSON, so it's converted that. And we can see the token. This is what we need. And I'm just going to drill into this because we don't care about the other bits of the data we're getting back. And this is our token. So what we need to do now is reuse this bit of code in all the subsequent requests. And the best way to do that is just to convert this into a function. So before I do that, I'm just going to rename this. And because when you turn something into a function, you get another object. Create function. And it's trying to identify some parameters it thinks you need for your function. So what this will mean is every time you try and call a function, it's going to ask you to fill these in. But you don't need to. These are already set as parameters at a higher level. And sometimes kind of the way it works is it misdiagnoses that. So we can just get rid of all this. So the thing that makes it a function is just like this bit of code at the top and the bit at the bottom. So by removing this, all the options are gone away. And if we were to invoke, we get a nice token. And we can refresh that. We get it's all looking good. So that is the hard part done now. We need to use this token just to create subsequent requests to get some real data. So if we want a list of users for workspaces, then we need to know what workspace is. The Power BI API is quite old, and it was made a long time ago, so it has all the old terminology. So it still calls semantic models data sets. Workspaces are called groups. They can't change these now because it would just break everyone's implementations. But essentially, we just need to make a request to this and give it the token, and we should be away. The only limitation is the service principal I created that has access into the API. If I run this call, it will only show you the workspaces for which that service principal is a member. And in your scenarios, that might be what you want. So you might have hundreds of workspaces, and you might just want to run this analysis on the ones you want. So you could give the service principal individual access to all those workspaces. What I want to do is run it across the whole Power BI estate. So in the admin section of the API, there's lots of other ones. And there's one which is get groups as admin. So that will kind of override the thing of whether it's in the workspace or not. So we can run this request, and the service principal will just get all the workspaces. So we're going to go off and do that. So back in Power Query, I can delete this. And once you have one version of this thing working, it's always better just to duplicate it and then change it to what you need. So I'm just going to rename this to workspaces. And we'll jump in and change a few bits. So it's no longer going to be a function. So we can get rid of these bits. And the URL is different. So back over in the documentation page, we're going to app.powerbi.com. So we'll change that. And the bit of the API we're using is this section here. So I can put that, and we don't need the tenant ID anymore. This top bit at the end, it allows you to limit how many comes back. But I'm just going to set it as 1,000. So, okay, well, what other bits do we need to get this working? So we've got our URL, we've got the path. We don't need this content type header, but we do need a different header because the token needs to be sent along in the header. So we can just do token, and now we can call the other function. So at this point in the Power Query, it's going to go off and it's going to get the token. And now our headers can be a bit different. We're not sending concept type. It's authorization with the American spelling, be careful. And it's a bearer token. And then we can just add in the auth token. So that's our headers. Our new request doesn't have any body. We don't need to do this bit. And we still have our relative path. We're not saying any content. We do have headers. And I think we're about there if I just delete this transformation section.
E on line 3, relative path.
Thank you. And let's see if that works. It's because I've been renaming things. Okay. And again, it's asking how to connect because it's a different URL. The first time we were going to login.microsoft.com. This time it's api.powerbi.com. Again, we can tell it it's anonymous. And we can go into this and we've got 19 rows, it says. We can turn that into a list, into a table, and then we can expand that out and we should get a list of workspaces. So we have all the workspace IDs and we have quite a few different bits of information that comes back. Now, when you run the API call as an admin to get all the workspaces, you do get everyone's like personal workspaces. So we're probably going to want to filter some of these bits out. So we can identify them by this. So we're just going to do does not equal personal group, and we can get rid of this admin one as well. So that's limiting the number of workspaces down. And I'm just going to give the ID number a proper name. Workspace ID, convert it to text. That will help it later on when it tries to create relationships on its own. And workspace name. So that's the workspace side of that. We just now need to go and get a list of users for these workspaces. And handily in the API documentation, right above it, get group users as admin. This looks pretty good. Returns a list of users who have access to the workspace. Okay, so we just need to run this URL now. So we go back here. I'm going to create a duplicate of this. This is going to be users. And we shouldn't have to change too much at this point. We're still going to api.powerbi.com. But we're just going to a different part of it. Now, this is asking for your group or workspace ID here, but everything else looks like it should be the same. So, and we obviously, the transformations will be different, so we don't need this part of it. So if I run this now, it will error because the workspace ID doesn't exist. So just temporarily, I'm going to grab one of these just to make sure it does work. Let's see. And I can click into this. We have a list of users. To table. And we have a list of users who have access to the workspace. So myself, obviously, John Smith. The service principals and entry groups will show up in this as well. They won't always have a nice name, but they have their identifier. You could go off to Azure Enter API and get the nice names and even the members of entry groups if you wanted to. But this is a good start. We just need to now run this on every single one of these workspaces. So we've made a function before for the token. We'll just do one now for this. Turn this into a function. Can't find any parameters. That's fine. We'll figure that out. function name is get users. And in the advanced editor, I'm just going to add a parameter. So before, when I remove them, I'm just going to tell it this function expects a workspace ID. And then instead of this being hard-coded, it comes out. So now we can call this function on every one of those rows, and it will go off and get the users, and it will return a table back. So the final thing we need to do then is I'm going to duplicate this again, because this is a filtered list of the workspaces. And this is the thing that is going to become our user table. And we no longer need anything else apart from this. And we can just do invoke custom function. This is up for our users. Get users. It wants to know the workspace ID. That was the parameter. It's already figured out. It comes from a column, and the column's workspace ID. So now we'll be going off and making those 12 different requests to the API, and every single one of those returns a table. So I can expand this. So now we get all the user properties and the workspace that was assigned to. So we're pretty much done. I'm just going to stop a few things appearing in Power BI Desktop. Like this one. Cool. So now we can do close and apply. And we have two tables. With any look, it's detected the relationship. One workspace, many users, workspace ID. So now you could go off and start creating a report that shows your workspace access, and you could use that in kind of an admin capacity. So let's say you want to know who's admins of what workspaces. This can become a slicer. And then we have our workspace name. And so, okay, well, every workspace will have an admin. So we need the names attached to that. So I will do identifier. And then, yeah, we can see who's an admin. So I'm an admin in most places. We've got the service principal as an admin in one place. Sheb's an admin somewhere. There. And then who's a member, who has viewer access. And as a starting point, that's pretty good. You could take this approach if you wanted to, like, in terms of governance of your Power BI estate. The API has lots of different calls. So you can get users of a workspace or a semantic model or a report. So you can imagine situations where you might say, give me a list of reports then and get me the users. It can end up being a lot of requests. But yeah, that is essentially it. And I'm happy to have any questions. Yeah.
I think I know the answer to this, but if you're in a high security organization that won't let you make a service principal, what would the workaround for that be?
You're stuck really.
User account.
You can get around it using your own credentials, but every time I've done it, it's been a bit hacky. And yeah, and the real answer is like sort out the internal politics of that and get them to make it.
Some feasible, possible, but others.
Yeah. So
how much access do you need then? So in terms of...
So the service principal itself does not need any special permissions within the Azure or Graph APIs, but in the Power BI service, there's a admin setting. So if I go to, hopefully it doesn't take me to a different tenant, which I don't need to see. No. So in the admin portal, there's a million settings. So the bits you care about is service principals can access read-only admin APIs, and you have to create a group and then put the service principal in the group.
Right, okay.
But if it's added into here, they can get read-only access, read-only APIs. Then there's the admin APIs, the one I use today. That's a separate setting. So if you're a Power BI administrator and you can do tenant-level Power BI things, you tell your administrators create a service principal. It doesn't need any permissions. and then you can come in and assign the permissions yourselves. So that helps.
Yeah. And is that just with the Power BI admin stuff APIs? What about any other APIs externally?
Yeah, so anything that's in the Azure Graph API, then you will have to get the service principal appropriate permissions.
Right, okay.
If you're going outside of your organization, then you're at the mercy of their documentation. Quite often they will send you the client ID in secret, and they'll give you an authorization URL. Because this is Microsoft, it's got this Microsoft one. But yeah, third parties will have their own authorization URL, tell you the ID in secret, and you do the same thing. You make the initial call, get the token, and then if the documentation is any good, you'll be able to see all the other requests you can make to get the data, and you just run those in the same way.
Okay. Any other questions?
I was going to ask about your requesting token on every request.
Yes.
Would you typically do that in the wild, or would you do it?
Like, it depends how good the API is and how much they care. With the Microsoft one, I would. But there are ways around that. Like, you need to be aware of how long they last. And so therefore, your semantic model needs to refresh within the time. You can't really create a loop in Power Query that says, if it's over the hour, generate a new one. But if you wanted to create one token and use it once, then what you can do is you can create a new blank query. And in your advanced editor here, you just say this is get the token. So this is now like an object, and that's been evaluated. And then if you reference that in all the requests, it'll be the same token every time. Sorry, Johan?
Can Power Query handle paginated responses from an API?
Yeah, you end up in more nesting in the results. And it depends how the pagination works. There's like a million ways. Back in the list of workspaces, the very first thing we got out of it is it gives you a row count. So, and it depends how I've worked with APIs where it says you have an offset. So you get 100 rows, offset it, another 100 rows, another 100 rows. If you know how many there are in total, you can make one initial request, see there's 500. Then you can use the Power Query function that generates a list. So you do 500 divided by 100, because that's all you can do. So you end up with 1, 2, 3, 4, 5. And that ends up, then you just call the function 5 times with the offset, appropriate offset. But then other APIs require you to go to like a special URL and embed that in the headers. It depends specifically on what they're after, whether you can do it in Power Query. Sean?
Given free reign of the whole Azure and Fabric Microsoft stack, how would you prefer to architect this?
Yeah, these days in a Fabric notebook, do it all in Python. But we're at the Power BI user group, so I don't want to go off topic.
It's data analytics now, so you're allowed to talk about it.
Oh, I'm allowed, am I? Yeah, so I did something recently to get all the emissions for a really big Azure estate, and you have to do it by subscription. And so I had to first say, how many subscriptions have you got? And it says like 10,000. And then you have to do, and then you can only do it by month. And you can only do it, so yeah, there's a lot of Python going on there. But then as soon as you're doing things in Python, you don't need to refresh it in full the whole time. You can save stuff back into a lakehouse and do merges and that kind of thing. Just run it every day and just get new records. Yeah, because now anyone that's on Power BI Premium has Fabric stuff. Yeah, well, they're not on Power BI Premium now. Then yeah, but it's a bit of a different skill. This is fairly complicated, but I would say it's more complicated to do it in something like Python in a notebook. But depends where your skills are.
Any other questions?
Can you body lecture? It's very shocking. You have 15 years experience.
Oh, sorry. Yeah, I'm older than I appear.
You look very young.
No, I've known Shep more than 10 years, haven't I? Yeah, it's been a long time. Thank you, though.
So my question is, how you compare the Power Query and DAX environment in Power Query?
So the Power Query stuff is, if you don't have a place to do ETL, then it is really powerful. And you can do all the transformations. You can do stuff like this. There becomes to a point where the scale gets a bit unmanageable, and you do need something behind the scenes, database, Fabric, something else. But Power BI, particularly on some like decent capacity, it can handle a lot of rows. You can go into the billions, and its reports still work fairly quickly. Everything's okay. It just depends. Like some APIs, if you API sources or database sources, they can be really slow dragging the data out of them. So that would influence your decision.
Next.
DAX is fine. Yeah, like if you make a nice star schema, like Shep will tell you how to do, DAX is easy. But if you go and inherit a really difficult data model with loads of relationships, and DAX can be really complicated. But clean data model makes DAX really simple.
When Copilot is helping for both.
Yeah. Like Copilot, ChatGPT, you can ask it questions, it gives you reasonable answers, up to heading towards advanced things. It's there. So in my opinion, it should be a tool we use. Yeah.
Any more questions? No? Thank you very much, Lewis.
Thanks, everyone.
We'll take 5 minutes there, so if you want to grab a drink, comfort break, we'll get Dr. Phil set up and back on our screens in around 5-6 minutes. Thank you. So we are ready to go. The sound is online. You are online. Can you turn your sound off?
Sound off.
Perfect. That should be perfect. Right, everybody. Thank you very much. Talk number 2. We've got Mr. Dr. Phil Winder. And I'll be taking us through some AI-related talks. Is that fair enough?
Yeah, that is fair enough.
Nice to see you. Best of luck.
Thank you very much. Where are you going? Hi, everyone. Right. So before we get started, I changed the name of the presentation to something a bit more snappy. Previously it was RLLM to better UX for analytics. Now I'm just calling it Vibe BI. So you've all heard of Vibe coding using AI agents to help you assist your projects, to help you write code, but you just sort of vibe your way through it. Vibe BI. This is a thing. My background is not in analytics. It's more in pure data science. I started in electronics. Started Winder.ai in 2013, and since then been doing lots of data-related stuff, but all the way through the stack from the point of where you're doing data science all the way up to sort of production deployment of models. So like ML, RL, MLOps, increasingly more stuff that you would call AI, but I'm starting to use the word AI to kind of encompass all of that now. Not an expert in analytics though, and not too much of an expert in data engineering either. So that's kind of where my expertise ends. So from your perspective though, what's your general experience level with AI and machine learning and things in general? Just want to get like a level to pitch at. Small, not much. Okay, I'll keep it there then. That's fine. So throughout all of my projects and work, the ultimate problem is always a people problem. It's always communication. It's defining objectives. It's communicating results. It's things like that. And when you're talking to AI, I feel like I still need to say the word please. And that's because it's mimicking human interaction. I don't want to forget how to say please to people. So I do still say it. This presentation is all about how I think, basically my challenges with dashboards as a user of analytics, not necessarily a creator of, constantly stressed out about the fact that I don't have the information I need at the right time. And one idea to get rid of that problem is to attempt to code it away. Like, can we write code-like solutions to that kind of problem? And specifically when it comes to large language models, they excel at writing code. So in this presentation, I'm going to talk a little bit about agents and what they are and how they work. I've got a couple of demos more specifically tailored towards analytics, but again, not an expert in analytics. So to you, probably looks really simple. To me, it's really complicated. Hopefully you'll learn something along the way. So what is an AI agent first? So it's a very overloaded term. It's super hypey right now. If you go on Reddit, it's everywhere. And there's lots of people that are very excited about it, and rightly so. Agents are a way of encoding a loop of work. So this is the definition of an agent from reinforcement learning. I wrote a book on reinforcement learning a few years ago, and there's a mathematical background to this. It's called a Markov decision process, and that's the formal definition of what an agent is. An agent is basically a loop that goes round and round and round and round. It has things it can observe, it has things it can do, and it gets rewarded for those things. So they're the only three things that you need to make a Markov decision process and implement an agent. So this is an RL view of an agent. This is the observation, it's known as the state here. This is the reward, and this is the action. So an example of a state in like a robot, for example, might be a video camera. The state, the observation might be coming from a video camera. The action in a robot might be move forward, move backwards, grab, lift, make coffee, things like that. And the reward is usually, have they done the thing correctly? Have you got a cup of coffee in your hand? When we're talking about like AI agents and sort of LLM-driven agents, typically the state is some combination of the user's request plus a load of other context. The action is try and achieve what the person is trying to achieve. It might be write code, it might be visit a web browser, it might be anything like that. and then the reward is typically you don't see it in the agentic loop, but ultimately the reward is success at that thing. So that's the RL definition of an agent. But when it comes to thinking about it in standard software engineering terminology, agents are basically just while loops. They're just loops that go round and round and round. They attempt to do something, they pull back a load more context, and then they see if it can make a decision about whether they can use that. So this is a slide from one of my colleagues, Luke, and yeah, he likes to think of them as very, very simple while loops. But they don't, in and of itself, a while loop isn't particularly useful. Really, the intelligence comes when within the while loop, you can decide to do something. You can decide to take some sort of action to help improve your observation of the current state, or maybe actually produce a result. And really, all of the intelligence comes from the tools that are attached to the language model inside this loop. So you can imagine all sorts of different tools, but the most common ones are search for something, find something, edit something, run something, things like that. And it's really that interaction with the real world that gives them some sort of semblance of intelligence. So really the goal now is for within the while loop, the language model basically decides, should I use this tool? Should I use that tool? Should I use this final tool? And it makes the decision as to which one to use. It uses it, pulls it back in to the context. It's now got this new context. And then the model then goes again. Do I need to use another tool? Do I use this tool? Or can I finally answer the question? So that's the agentic loop. So this is a bit of a flow diagram that depicts what's going on here. And we've got two colors. So the first one, the first color, the yellow color, is supposed to represent a predictive action. So something where it has to take a guess. The blue ones are usually they're concrete calls. They're systematic. They're can't remember the word. But anyway, so you start off with the interaction. This is the user's query, typically. And then we go into this loop here. This is an additive loop. We're intending to try and improve the context on each time. So the first goal is to try and predict whether the next thing is, we call it actionable. It doesn't really matter about the language there, but predict whether we need to use a tool and specifically which tool. Then the next step is to predict which tool. And then the final one is to, once you've chosen the tool is usually exposed as a function, and you need to predict what goes into the parameters of that function so you can call it correctly. So this can be anything. Functions can be move cursor to here if you've encoded some sort of playwright server. It could be search the web for this query. It could be anything. You then call the function, return the result. Typically, don't do much with the result. You just stuff it back into the context again and keep going around the loop. Eventually, the LLM decides, actually, I don't really need to do anything. I'm not going to learn anything by searching the web again. I'm not going to find anything else in any other files. I'm just going to go ahead and try and predict the answer. And I keep saying predict here because you have to remember that language models are models. They are predictive models. The whole ethos is to attempt to predict words. And it's within that prediction step that allows it to predict whether it needs to call a tool or whether it can actually predict the answer. The challenge with that is that you have a lot of prediction steps in here, and predictions are never 100% accurate. You can't predict the weather with 100% accuracy. And so predictions only work most of the time. So most of the time you get good results, but sometimes you don't. So I need to get that t-shirt printed and say that I work 95% of the time, because that is so true with any ML model. And whenever you start stacking these things together, we've already got lots of predictions going on here. Any one of those could fail. If you start going around in loops as well, any one of those loops could fail. So actually, one of the most common failure modes in all of this is that it gets stuck in a loop. It keeps repeatedly trying to research the web because it's got a little bit more context and it thinks it can't quite answer the question. So I'm going to search the web again and again and again and again, and it goes around and around. So these things need a lot of monitoring. They need a lot of control. They need systems in place to thoroughly test that it does what it's supposed to do, because they're very autonomous. So let's try and have a look at some of the components of that diagram actually in code. I don't know if I can kind of make that a bit bigger. No, it's not working. Okay, hopefully you can see it. So this is a bit of Python code. It's using a library called Pydantic.ai. That's not special. There's 1,000,001 agent frameworks out there today. They all basically try and do the same thing, but expose the primitives in slightly different ways. The common sort of consensus is if you are building production systems, if you're actually building a proper application, then you probably shouldn't use any of these frameworks. You should actually develop it yourself for your specific use case. So that kind of gives you a clue at how useful these are in the long term. But I quite like Pydantic because it's quite simple. The primitives are simple. I think the primitives are at the right level. Yeah, maybe let's take you through it. So we talked about the various parts of the problem that require prediction. In order to generate that prediction, you need a model. And the model is selected at the top here. There's lots of different models you can use. This is selecting one from Winder.ai, which is one provider of a service that gives you access to some of these models. But you can use open source models, you can use local models, you can deploy models on your own GPUs and use remote models. You can use other providers, so on and so forth. So these access to these models is quite democratized at this point in time. Then we've got a prompt. So this is the initial instruction, the initial prompt that the user is providing. Yeah, not very interesting there. The most interesting bit is when we start adding tools. So they call them tools here. I'm still not sure of the terminology tools. I don't like the word tool because it sort of implies it's just this one discrete thing, like a spanner or something. I prefer the word like skills rather than tools because these can be actually really complicated. You can have a set of tools that are designed to do a specific thing. Like a really common one at the moment is called deep research, which is again this agentic loop connected to web search, doing lots of summarization and stuff. It's kind of like it's a single thing, but it's not a tool. So it's like a set of tools to do a thing. I don't know, it's bad. So anyway, in this example, we've got a very simple tool called add, and it just adds two numbers. The interesting thing about the way that Pydantic defines its tools is that it's kind of using lots of context here. It's using information about the type hints on the parameters there, and it's passing that to the LLM. It's providing the doc string to the LLM so it can decide when it needs to use this tool. And there's other things you can add as well to basically give the LLM even more information about when you should use this tool. Then we've got a main function, standard stuff there. So this, sorry, I got the wrong. That's the system prompt. This is the user prompt. So this is the interaction, that first box in the while loop there. And we've got a couple of simulated user interactions there. And then we're just going to run the agent. So inside this agent run command, this is the agent defined here. Inside this agent run command, that's basically doing the while loop for us. It's saying, do I need to call a tool? If yes, call that tool, run the loop again. And it keeps doing that until it doesn't need to call a tool anymore. I'm storing a bit of the message history in there, and then I'm printing out the result. So I actually spun up a little repo with that. I'll put a link up again at the end. Let's just have a look here. So this is that code in real life, and I'm just going to comment that out actually to begin with because that was quite an interesting result. So same code as what we just saw. I'm going to run it. Just running that Python code. UV is a fairly modern package manager, which is a bit like NPM, but for Python. So it kind of encapsulates your Python environment really nicely. Check it out if you're using Python a lot. And here it is. And we've got the user interaction here, defined by user. We've got the response here, defined by the prefix AI. and you can see the responses. The interesting one is the last one. So I've asked the AI to add 5 to the previous, well, I mean, I haven't asked it to do it, actually. I've just implied that I'd like you to add 5 to the previous result. And it has no idea because I just removed all of the history. So you have to remember that every time you call one of these models, you basically have to pass in everything that you think it needs in order to do its job. And quite often that's history. That doesn't happen by default. You're just making an API request like we were a second ago. You need to include all of that context and include all of that data. And that's what this special parameter is doing here. We could also build the context ourselves, but this is just like a helper parameter to pass in the previous history. And when I re-add that, then it does give us the correct result. The interesting thing, though, is that it is using in the background. So let me actually try and do this, actually, see if it does it. Something like that. And let's run it again. So in the background, you can't see it normally, but it is actually deciding to use our tool. So you can see here using 2 and 2, using 4 and 5. So it's actually using our addition tool there. So maybe let's actually try altering this to something crazy, like something that's not adding 2 numbers. Remove items from the cart. Let's make it completely not relevant and see what happens. There, you see now it's actually not printed that string out there, and now it's not called our tool, and it's using it's so people bang on about hallucinations. Hallucinations are not a bad thing. They're exactly what we want an LLM to do. We're using it as a predictive model to predict our result. It may not be the correct result, but it's a result. And so here we have hallucinated that 2 + 2 = 4. And adding 5 to that gives you 9. So actually, it just proves that we didn't need a tool to do that in the first place. But you can see how it's using the doc string there as a way of figuring out whether it should use the function. So even when you're writing code that uses LLMs, you're still basically prompt engineering everything. It's one giant prompt engineering exercise. So you need to, ideally, you need to test this, and you need to have scripts that prove that you haven't broken things by changing doc strings. Okay, so that's that. Right. But back to the whole point of the presentation. So I, as a small business owner, spend a lot of my time on web analytics. And ever since GA4 came out, I've just been unable to use Google Analytics. And it's because of the UI, it's because the interface. I never know where to find anything. I hate the fact that I have to build reports for everything. Like I shouldn't have to do that. So is there a way of actually allowing me to ask questions of my data without having to point and click in just a totally random way to get results that I want? And so that, you know, speaking to Sheb about this, I was thinking about how you could actually do this more in general. Actually, I was thinking more, if an organization has data and it is siloed and not accessible by the rest of the business, what better way than to expose that information via some sort of natural language interface, like an LLM? Can we just talk to the data in the marketing department or in the sales department or whatever? So this is just a similar idea based upon that, really. And so my next demo is a little bit more complicated than this. Not much, though, not much. Right, so I'll go through that again. Let me just move. Can't see the line. There it is. All right, so for this demo, I'm actually pulling down some data from BigQuery. Where's the actual definition of the table? Here we go. Google offer a very nice set of public data that's available for anybody to use as part of their demos. And one of those data sets is an obfuscated GA4 e-commerce website. I think it's from one of their own websites, actually, and they've anonymized all of that data and released it to the public. it looks very much like normal GA like data, like users, events, things like that. And I'm using the Python BigQuery client in order to actually get access to that table. So it's actually the Python library that is doing the listing of the records and the querying of the stuff. Right, what else have we got in here? So here's my agent again. I'm using the same tiny little model from OpenAI, slightly different system prompts here though. So first off, change the system prompt to basically describe what I'm about to do here. And I can't even spell right. Answer queries about website user behavior and e-commerce performance. Here's a list of valid fields that you could query. So I decided that because this data is static, I can just dump all of the information about that data in the system prompt. You could also create a tool that allows the agent to actually query what is available itself, but I found it more reliable just to dump it. The table information, the table structure is not that big, so it doesn't take up much room. I found it easier to do it. But yeah, in the real world, you might have tools that allow you to like list tables, list fields, list descriptions of those things if you've got access to them. Then we've got our first tool, and this one is to query BigQuery. So I'm being very specific about which table it should query. It's going to query this specific table, and it must be a valid BigQuery SQL query. And also I found that it struggled with timestamps a little bit. So I kind of helped it out in the prompt to tell it which function to use for this data, this timestamp micros function, rather than just like a timestamp seconds function. It was struggling with that a little bit. And so the goal of this is for the LLM to actually predict a SQL query and return some results based upon some user questions. So let's go ahead and run one of these. Fingers crossed it works. So I've commented the rest of them out. So it's listing the fields. So that first line there is a print of the SQL query that it generated in order to satisfy my request. Looks good. Run a query to find out what time period you have access data to, and it's basically listed all of the results and min-maxed the timestamp and said that the first set of the first data is October 31st, 2020, and it goes up to February 2021. Okay, awesome. So imagine this in like a slick UI, where I'm just sort of typing things into a pretty. I'm often jealous of like front-end developers because they get to make like pretty things all the time, and my stuff's never pretty. What was the total revenue generated in November 2020? It was 144,000. Yeah, simple sort of aggregation there. It's just doing a big sum over all of that. Let's start adding a few more. Go a little bit faster. I should have commented that one out. So these are somewhat. Whilst I'm doing this, somebody if you've got an interesting question you'd like to ask it, just to see if it breaks or I don't know, whatever. Have a think and see if you can think of something interesting. So now we're doing some slightly more advanced analytics, I would guess. We're starting to not just ask for data from specific months, but also ask more general questions like which month had the highest revenue. And it's found that December 2020 had the highest revenue, which traffic source provided the highest revenue. The highest revenue was organic, and that had a total of 104,000. Then you can do some even more stuff. Now I'm asking it to split the traffic sources and do some comparison. So what's interesting about this one is that you see it's actually made two queries. So this is a demonstration of that agentic while loop. It it generated one query and ran it, and then realized it didn't actually have all the information it needed in order to answer the question. So it generated another one and ran it again. And there we go. So it's ran one for December, one for November, and then it's doing a comparison. So again, this is the model doing this. There's no tool that's doing any calculation there. Cool, eh? So the last idea that I had was, so that's great. It's all text. Oh God, I can't see that again. There. What about, can we just try and generate a query that formats the data in some opinionated format, JSON, CSV, something like that, and then plot it? Can we actually automate the full dashboarding-like experience? Now, if you look at this tool and squint a little bit and imagine it's a fancy dashboarding suite and not just a very simple plot of an image, an image of a graph, then hopefully you'll be suitably impressed. This is basically another tool that allows the agent to plot a line chart based upon some X data and some Y data, and allow it to pass in titles. So again, we're using the doc string to kind of express what it's supposed to do. We could add like annotated fields here to kind of give it a bit more of a description about what the data actually is. I found that this worked okay. And then if I run that one, plot the revenue for each day for all the data you have access to. Fairly simple query, I must admit. Just running that query. Come on. Yay. There you go. And that's a plot of just a simple graph of the revenue per day for all of that. So has anyone thought of any good examples that I can try to demonstrate that AI is not going to take over the world? Anything? Anyone like me to try?
Something about growth from the last year.
Growth. Okay. So I've only got like 3 months worth of data, but I can, how much growth have we had over, oops.
Can you tell me which products?
Not sure if it's got access to products, but let's just run that first and see what happens. So the trick is to not go too cocky too soon, because if it fails on an early one, it's certainly not going to get a more complicated one. Okay, so there you go. Oh, interesting. So from growth, it's just picked number of active users, not really sales. So we'd have to be more specific if we were talking about in sales. Right, whilst that's running, I'll also prepare this. Oh, interesting. I decided to plot that as well. Okay. So I guess if we wanted to actually talk about growth, we'd have to give a time period in which to compare it to. But that seems, I mean, obviously I don't know the underlying. It could have just hallucinated all of those numbers. So I guess you would have to check that. But yeah, I mean, looks good. All right, thanks for that. Yeah, you can see this code yourself at this URL. I'm maybe just I'll pop that up at the end. So that was actually a reasonably simple demo, as in it's fairly easy to do, it's fairly easy to get started, fairly easy to run. What would you do next? Well, the next thing, and this is where it starts to get a little bit more complicated, is you start splitting up the problem, just like you would any other engineering problem. You split up the problem into smaller parts, you parallelize it, you linearize it, you know, in order to define what the process is. And you can build agents for all of those discrete parts. You can have agents that are specialists in the business domain, agents that are specialists in data engineering, so on and so forth. And all of those can communicate with each other in order to achieve some desired result. The benefit of that is that in some ways it becomes easier to test, because the scope of each agent becomes smaller. It's easier to write a test set to actually prove that that does one thing quite well. But in other ways, it actually gets more complicated, because again, you've not just got one while. I've already said how not unreliable is not the wrong word, but how random a single while loop can be. Imagine when you've got like 4 different while loops, all doing their own thing, all trying to feed one higher up while, you know, there's chaos basically. And so again, the hard part is actually orchestrating and managing all of this. It's not really the building of the agents itself. All right, so just a couple of things that you might find interesting. Just a quick add-on here. So first one, I do lots of webinars and blogs and whatever. So if you're interested in learning more about any of this, then sign up to our newsletter on Winder.ai. Couple of other things that we're working on right now. So quick shout out to Helix. Helix ML is one of the companies that I founded with a few friends, and this is specializing in on-premise LLM applications. So the idea here is to provide a completely secure, safe, private LLM stack to kind of mimic and replicate some of the functionality you get in like OpenAI or something like that, but entirely on your own hardware. So for people that have really sensitive data, so think like super secret hedge fund type people, or you have a regulatory burden to keep your data really, really close to you, like telcos, healthcare, something like that, then something like this might be of interest to you. Something I'm working on right now is an open source project related to Helix, where if you've ever used an AI coding assistant before, one of the challenges that you'll have is that the quality of the prediction, the quality of the code that is generated, depends very much on the context you can provide the LLM. So most often it's like being very, very verbose, writing exactly what you need, how it should do it, things like that, but also providing other examples, providing other code. So Helix ML Codeit is an MCP server. So that's a special plugin basically that you can plug into LLMs that allows an LLM to retrieve more context from other code sources. So you can index your local directory, index your computer, index GitHub repositories. Eventually we'll be indexing like documentation and stuff, and all of that will get fed into the LLM when you're coding to allow you to provide, basically look something like this on a beach. All right, so conclusions. AI agents are a new paradigm in general, but I think that they're probably here in the analytics and BI domain as well. I'm not too experienced in that field. You've probably seen more than I have. But as a user of analytics and BI, I think it's a very powerful way to democratize, it's an overused word, but democratize data. Knowledge is provided by connecting data sources. As you saw, all of the power in all of the intelligence that an agent has basically comes from its tools, from its data it can get access to. But reliability is a challenge, and that's really where all of the engineering work is if you're ever embarking on any of this. So yeah, this talk was very much the first part of the meme of how to draw an owl. that was just a simple demo, but I definitely recommend check it out if you think it's cool. Plug it into your own stacks, into your own data. Oh yeah, just like this morning, I was on Reddit and there was a guy that did basically this entire talk, but he wrote an article about it. So totally independently, someone's done a very similar demo. So it was interesting to see that. So I thought I'd give a shout out to him. And if you'd like to keep in touch, then Dr. Phil Winder on LinkedIn or Twitter or anything else. Thank you very much. Any questions? Sure.
Yeah. Thank you for delivering very technical skills. One thing is that you avoid winning. What things led you avoid winning in the consultancy?
So I think what you're referring to is we did a project for Stability AI. They're an AI company. They're most famous for Stable Diffusion, but we helped them build a product called Stable Audio, which is a music generation model and service. You can go to stableaudio.com and generate music. It's really, really cool. And we got on Time's top 100. I can't even remember the name of it now. It was some Times list we were featured in. So that was it. That was the most recent one.
So as you're an electronic engineer, there's a very big scope of AI hardware side as well. What thing led you to the software?
That's a long story. I think in short, I was already writing a lot of software in hardware. I was already writing in embedded languages and C and eventually C++. And I saw that the hardware was basically just turning into becoming mini computers. You know, even before Raspberry Pis or whatever existed, there was a long history of mini Linux-like embedded systems that were being used as the brains of all electronics. So I thought, I need to learn some software here. And so I kind of pulled out and started learning some software and brought all of the machine learning along with it.
So there is a very big scope and competition of AI hardware as well.
Mm-hmm. Yeah, definitely.
Globally.
Yeah, definitely. Yeah, and there's not too many UK companies actually that specialize in hardware. Like ARM, for example, I think sold out to various foreign companies now, which is really unfortunate because they were best positioned to be able to take advantage of this. But there's a few. There's GraphCore down in Bristol. They're making some quite sophisticated neural chips to do like proper deep learning, parallel computation, basically. So that they're quite interesting. There's a couple of others as well that are starting to spin out from universities. Yeah.
Make money.
Potentially, yeah.
More than software.
Yeah. Maybe. Anyone else? Yeah.
When you're running the OpenAI model through Python, is that all happening locally in your PC?
No.
So it's going up to the next two.
Yes. Yeah, exactly. So that's like as I'm sure you're very aware, you've got to be careful to remember where the API boundaries are, because it's very easy to transmit data to somebody else when you shouldn't be. Yeah,
that's fine. Just wondering.
I can ask like 100 questions. I won't monopolize your time afterwards. But I think an interesting one for the rest of the group, coming from a sort of consulting perspective, you spoke at the start about a lot of the challenges in the area actually about communication with clients. With something like agentic sort of workflows, you point out that a lot of your work ends up being prompt engineering, and if we're deploying these in the wild and trying users that don't have that kind of background, a lot of what we do is about explaining maybe the limits of the data or the limit of the analytical method that they're applying. Could you talk to sort of, with your sort of 10 plus years doing this consulting in AI, how you've kind of encountered that in the wild, how you've spoken to your clients about how to conceptualize on AI, and how do you sort of get them to understand and accept both the limitations and the risks?
Yeah, that's a great question. I think there's many angles actually. I'm just trying to pick a couple that are the most interesting. So I think the first one is it depends on who you're talking to. So for the first 10 years of my company, I was principally talking to other technical people. I was speaking to engineering companies, you know, or at least engineering heavy companies, like either tech companies or maybe like oil and gas companies or traditional kind of engineering companies. They already had a grasp of technology and quite often a good grasp of maths and statistics and things like that. So it's quite easy to communicate with them because you've got similar, what's the word? You've got
Shared language?
Yeah, that's it, a shared language, exactly, yeah. But now I'm speaking to like normal people who are trying to do AI, and that is incredibly difficult because there's no shared language, there's no shared history of technology, and trying to explain to them that, like, yes, you could automate it, but it's never going to work perfectly. Well, they're like, well, why should I use it then? It's like, because it works a lot of the time, and it can assist someone to do the job very well in much quicker time than they could before, so on and so forth. So I think trying to communicate probability to people is hard in general. Like, I know like health practitioners and doctors and stuff. Like we recently had some health stuff, and we're trying to get the consultant to actually commit to like, should we do this or should we not do this? And if we do this, like, what are the chances of this happening? It's like, maybe, possibly, maybe, you know, and they go through the same sort of dilemma.
So have you done the work sort of creating and distributing standard operating practices in using particularly LLMs and agents for AI identity? Is that sort of where my mind is? It's sort of kind of trying to codify how you should be interacting with these tools, try and it's a contract of service for the user.
Kind of, but the whole promise of it is that you can communicate in natural language. And yeah, I think no, not being involved in any standards or anything, but obviously involved in trying to help users to use it better and get better results. And quite often that's explaining that you need to be quite verbose and actually describe what you want. And actually a prime example is, especially for the coding stuff, a lot of people use AI like they use a search engine, and they type in a single word like cars or whatever it is they're interested in and expect the search engine to return good results. But an LLM can't do that because it doesn't have enough context about what you're actually looking for. Are you searching for a car? Do you want to buy a car? Do you want to build a car? Like, what's the context behind it? Yeah, prompting people in order to give better prompts is probably the way to do that. Yeah, there is. Anyone else? All right, thank you very much. Cheers.
Thank you very much, Dr. Phil.
All right.
Thank you, everyone. Hope that was all right and you enjoyed 2 different chats we've had this month compared to the previous few. Next month, as I said, still trying to get some speakers together. There is SQL Bits next month, so it might be that we give it a miss and we're back in July, where we've already got speakers set up for July already. Anyway, got some food on this side, a little bit different from the previous month as well. So help yourselves to plenty of food, some more drink. We'll have a bit of networking, and then we'll be off in about 45-50 minutes. Okay, thank you very much.
Thank you.